GATE 2018 Civil Engineering Set 1 Question 4. A column of height h with a rectangular cross section of size a into 2a has a buckling load of P. If the cross section is changed to 0.5a into 3a and the height is changed to 1.5h, the buckling load of the redesigned column will be. The four options given are A. P by 12, B. P by 4, C. P by 2 and D. 3P by 4. The relevant NPTEL reference has been cited. Coming to the useful data, so one needs to know about the Euler's critical load formula to solve this problem, which is given as PCR, which is the critical load, equals pi square E into I minimum divided by L square. Here E is the modulus of elasticity, I minimum is the minimum moment of inertia, so the column's cross section can be L cross B. So we need to consider that moment of inertia which is minimum. There will be one value which will be larger, there will be one value which will be small. So we will always consider the smaller value, that is I minimum, and L is the length of column. This equation assumes that both ends are hinged. In case both ends are not hinged, an additional factor of k is introduced in the equation, but it won't be needed for this question, but should be kept in mind for other questions. So in the given question, the column's critical load is given, which is P. Its cross section area is A into 2A and the length is h. Another column whose load is not known, let us call it P dash. Its cross sectional area is 0.5a into 3a and the length is given as 1.5h. So for P, the value will be pi square E I minimum, let us call it I minimum 1 divided by L1 square. Here pi square E will remain constant as it is only dependent on the material. So let us call that C. We need to consider I minimum. So what we will do is we will take 2A and we will cube A. This is done because we need to minimize I. So for a rectangular cross section whose width is B and depth is D, the moment of inertia about the vertical axis will be given as dB cube by 12 and the moment of inertia about the horizontal axis will be given as B d cube by 12. So the inertia that we consider is the minimum of the horizontal value and the vertical value. So here if we cube 2a, we would not get the minimum value, so we are cubing only a, and we will also do similar for the other column where we would cube the smaller value, not the larger value, divided by the length square, that is h square. Similarly for the other column, P dash equals pi square E, its inertia will be different, I minimum 2 divided by L2 square. So pi square E will remain the same. C, I minimum for this would be 3a into 0.5a cube divided by 12 divided by 1.5h square. Let us call this as equation 1 and equation 2. If we divide P by P dash, that is equation 1 is divided by equation 2, we would get 2 into 1.5 square divided by 3 into 0.5 cube. Taking P dash to another side, we would get P dash equals 1.5p by 18, which would become P over 12. So the buckling load of the redesigned column was found out as P by 12, which is option A. The relevant NPTEL reference has been cited.